Okay, so we're skipping ahead to section 2.9, and the reason we're doing that is we just finished talking about the inverse of a 2 by 2. What the textbook does is goes and teaches row operations because you need them to do the inverse of a 3 by 3 or 4 by 4 or anything higher. Remember, an inverse is only of a square matrix. But what I thought I would do is just jump to finish inverses first, and then we'll go back and use this for other things. Okay? So this row operation rules and this technique we're going to use is to find an inverse of a 3 by 3, but it is also used to solve systems of equations in the other sections. Okay? So what I did just on the first page, we wrote down all of them. We'll go back and talk about what each of them means as we do it. But basically, we're going to have a matrix, and then there's a technique to what we call row reduce the matrix. So basically going through and changing the rows so that they have ones and zeros in them. That's why I say down here ones and zeros. And then we'll be able to read off our inverse. Okay, so there's a whole technique, and that's what we're going to do. The row operations that are legal, that you're allowed to do to a matrix, and it doesn't actually change the matrix. So I want you to think about a row, an equation. Okay, so if we think about an equation, x plus y equals 1. Okay, there's an equation. So this first one says we can multiply or divide a row by a non-zero constant, and it still stays the same. So what you're doing is, if you multiply this equation by 2, isn't it still the same equation? It's just in a disguise. So 2x plus 2y equals 2 is still the same equation. And that's what this row operation is saying. We're not going to have the x's and the y's, we're just going to have the numbers, but we can multiply a row by a number and it's still the same. So that's what the first one's saying. This is saying we can replace a row of a multiple of itself and another row added together. So this is saying, when we do elimination, we do this exact step, which is we've got two equations. So let's say we have the equation, say our system was x plus y equals 1 and minus 2x plus 3y equals 6. Okay, let's suppose those are our two equations and we wanted to solve. We might multiply the first one by 2. So multiply by, a multiple of itself, multiply by a number, and then add these two together, right? And why would we do that? Is to eliminate the x. Right, so that's what the step is saying, is that we can replace a row by a multiple of itself in another row. Okay, so we can add rows together, and we can switch rows. Does it make sense if you have two equations, and I write them this way, or I flip them around and write them this way, that's still the same two equations? Right, so that's what row operations are saying. I already do them, we just don't put them in a matrix to do it, and that's what we're going to do. So we'll go back to these in a minute. Now, the actual recipe to find the inverse involves making ones and zeros. And why do we do that? Well, when we multiply a matrix and its inverse, what do we get as the answer? The identity, which is ones and zeros, right? So what we're going to do is take the matrix, convert it to ones and zeros, and all the steps we did in the process is the inverse. It's like going backwards, how to get from that matrix to the inverse. Okay, so we're going to make ones and zeros. I've got the steps written down here, but we'll actually do them and you'll see what these mean. Okay, so those are in the notes. So we'll do a 2 by 2 first, the process, so you can see that you get the same answer, and then we'll do the bigger ones. So we are going to write down a 2 by 2. So the instructions will be find the inverse of Okay, so we're going to do it two ways, and we'll get the same answer. So using the formula is what we did last class. So what is the formula for a 2 by 2? Did you miss that? So I'll just squeeze the formula in here. So the inverse of a 2 by 2, 1 over AD minus BC. And then what do we flip? The main diagonal. So this would be DA, and change the sign of these two. Okay, so that's the actual formula. So that's what we're going to do for part A. So A inverse equals 1 over 6 times 1 minus 4 times 1. Switch the 6 and the 1, change the sign of the 4 and the 1. Multiply the half in. Half times 4 minus 2, and 3. Okay, so there's our answer. Now, if that were all we were doing, and we were just looking for the inverse of that, and that was the end of the question, what would you do to check it, to see if it was right? You would take that inverse and multiply by the original, and what do you get as your answer? I. 1's down the diagonal, 0's everywhere else. Okay, so B, this is the one where we don't know the formula for this yet. So B, row reduction, we're going to step 1, write the augmented matrix. AI. So in 2.1 I talked about what an augmented matrix is, and it's basically sticking two matrices together with a line in between them. Okay, so we're going to write the augmented matrix as step 1. So what does that look like? A is 6, 4, 1, 1, and we're going to augment that with the identity. So that's what the first step looks like. And step 2, we're going to use row operations until we have I on this side. So basically we're going to figure out how to change this 6 into a 1, a 0, right? So that instead of A on this side of the line, we've got I, and what's over here is going to be the inverse. Now step 3 is to write A inverse equals and take it out of the bracket. Okay, you don't just stop with it augmented and say that's the inverse, because it's not. It's part of the equation, but this is a great big matrix. The actual inverse is right there, so we would write that out. And step 4 could be to check your answer. And to check your answer, take A times A inverse, so the original times your inverse that you found, and multiply, or the other way around, it doesn't matter. Either way you'll get I. Okay? So, the row operations is what we're going to, and I wrote them down on that first page, but it's easier to see them being done than it is to read what it actually meant. Okay, we'll go back to what I wrote for 1s and 0s after we do it. So this is the process. Now, of course, with this one, with the 2 by 2, we've got 4 numbers to change. Well, unless one's already a 1 that we want it to be a 1, or a 0 that we want it to be a 0. But at most, we've got 1, 2, 3, 4 numbers to change. So there's 4 row operations to do. How many would there be in a 3 by 3? 9. 4 by 4? 16. I never even bother doing a 4 by 4. The process is identical. unless I gave you lots of ones and zeros, because 16 steps is a bit much. 9 steps takes at least a whole page, maybe more if you write large. Yeah. This is much easier with just 4 steps. So that's why we're going to start with the 2 by 2, even though we know a better way to find the inverse than this. Okay. For a 2 by 2, you are probably going to stick with this formula because it is much, much quicker than doing row operations. But you can always do it this way if you wanted to. It doesn't matter. Okay, so we're just going to write this question on the next page because we really need the whole page to show it. I don't want to stop in the middle of the page. So our question, I'm going to start with our augmented matrix, 1, 1. We augment that with the identity. Okay, so legal row operations are to make a 1, you have 2 options, okay? I didn't write that here, but to make a 1, you divide the row that you want the 1 in by the number in the place that you want a 1. Okay, I don't know if you read that, but we want a 1 right here, 6, so we divide that row by 6. Wouldn't that make a 1? Yeah, there's a better, another option, not a better option. Let's write it down here. The other option is to switch with a row below it. Below it is really, really important, okay? Because once we fix the top row, we don't want to switch it down to the bottom and then have to start over again, okay? So you can always switch rows. It's legal to switch rows at any point, but when you're doing a row reduction technique, you only ever want to switch with the row below it, okay? So why did I say that's a better way for this one? We have a 1 below it. So if we switch the 2 rows, we don't need to divide by 6. We can divide by 6, but that'll give us fractions, and then you have fractions through the whole thing, right? We know we probably are going to end up with fractions because inverses usually have them, but if you can hold off on the fractions for a little while, that's better. So to show a switch, remember I labeled these like row 1, row 2, like that? So to actually do our row operations, we write what we're doing over here beside the row. So to make a 1, I always put a square around the number I want to be a 1, okay? And my row operation is going to be switch row 1, so a double arrow with row 2. Now be very careful that you switch the whole row. That means the 1s and 0s go with it, okay? You have to switch the whole row. So 1, 1, 0, 1, 6, 4, 1, 0. If you don't switch the entire row, you're actually finding the inverse of the wrong matrix, right? So, because this matrix is now different than that one. So we want to switch the entire row. So there, we've got a 1 in that top spot, and we're done. That 1 should never change or else you messed up. If by accident that becomes another number later, you messed up, okay? It should never. So go back and say, what am I doing wrong? People go in circles all the time with these, but if you follow my recipe, my steps, you will never go in circles. So once you make a 1, so make a 1 in the top left corner. So that's done. Make a 0 below it. Whoops, below it. So I'm going to put a circle where I mean. It's right here. We want to make that into a 0. You make your 1 first, and then you finish that column with zeros. Okay, so we're going to make a 0 here. Now, to make a 0, what did I say? So this is not going to make as much sense until I show you. But here's what I said for making a 0. To make a 0, multiply the lead 1. You may be able to guess what that is, but it's the 1 that we just made. It now has a name. It's called the lead 1, or it's called the pivot. Okay, different books, different people call it different things. But that 1 that we just made. Multiply the lead 1 by the negative of the number you want to be 0, and then add the rows. Okay, so let's look at what I mean by that. I want this 6 to be a 0. So I multiply the lead 1, which is right here in the square, by negative 6. The negative of the number you want to get rid of. So if that were a negative 6 and then I add them together, won't that make a 0? Okay. So this is where we're going to write the step. Right here beside row 2, because we're changing row 2. Okay? So this step goes right beside row 2. We're changing row 2. How are we changing it? We're multiplying row 1 by negative 6. Negative 6 times row 1. And then we add it together, plus row 2. So negative 6 times row 1, because you can do that. You can multiply a whole row by a number, and then you can add rows together. So we're going to replace it with that. So let's just do that off to the side. Negative 6 times row 1. So that means multiply everything in row 1 by negative 6. So negative 6 times 1, negative 6 times 0, and negative 6 times 1. So I multiplied negative 6 row 1, and then add it to row 2. So let's just put row 2 here. 6, 4, 1, 0. Add them together very, very, very carefully, because this is where people make mistakes. And if you even make a small mistake here, it carries through the whole thing. And then rewrite it. So we didn't change row 1, because we were changing this 0, or this 6 to 0. There we are. Okay, so we've done 2 steps out of 4. You always make the 1 before you make the zeros, because you need the 1 to make the 0. So, where's the next 1 need to go? Where the negative 2 is. So I'm going to put a square because I'm making a 1. That's just my own technique, because when you look back, when you've made a mistake, you can sort of relate the step to what you've done. If you sort of keep it straight, a circle looks more like a 0, so I put a circle around any zeros. How do we make a 1? That's in row 2 that we want to change. To make a 1, there's 2 ways we can do it. Divide that row by whatever number's there, negative 2, or switch with a row below it. Is there a row below it? No. So what we would not do is switch with this because we see a 1 here. Why wouldn't we do that? That's bringing this whole row down here. We've messed up the top one if we do that we already put there. Right? We now have a 0 in the top spot, and that is wrong. Right? We want the 1 in there. You can only ever switch with the row below it. There's no row below it, so our only option is to take row 2 and divide by negative 2. So you just do that. We're not changing row 1. We're dividing everything in row 2 by negative 2. Negative 6 over negative 2 is positive 3. There. So making a 1 is always easy. You either switch row with the better row below it or you divide. The problem with making a 1 is that you do get fractions, and then you have to add fractions and stuff later. What do you think is next? The 0 right here. And then we've got the identity once that's a 0. Okay? So this is in row 1 that we want to change. So I'm writing that step beside row 1. To make a 0, here's our pivot, our lead 1 that's staying there. We have to use that to make that into a 0. You always take the row that has the pivot in it, which is row 2, and multiply by the same number but the opposite sign. Well, that's a 1, so this needs to be a negative 1. The same number but opposite sign. So negative 1 times row 2. So you multiply that row by the opposite sign so that when you add them it becomes a 0 plus row 1. So negative row 2 is just changing the signs. Add it to row 1. And this will be our new row 1. Now this is the identity, so the stuff over here is the inverse. And so we then take it out, A inverse is equal to 1/2 minus 2 minus 1/2, 3. Is that the same answer we had earlier? Yep. And then you could check it. We checked it by comparing it to the one from the question before. Okay. So what's going to happen if a matrix has no inverse? What do you think? Any ideas? So if it has no inverse, what's going to happen is you're not going to be able to make the identity on this side. It won't work. You'll get a row of 0, so you can't make a 1, because you can't divide a row by 0 to make a 1. So that's what will happen. We're going to do a 3 by 3 that works, and then we'll do a 3 by 3 that doesn't work, so you can see what that looks like. Okay? So, example 2, we're just going to say find the inverse. Okay, so step 1, put it into an augmented matrix. So really what I want you to think about on your page to keep things sort of neat is, let's just put a line here. I'm going to do my calculations over here. And then about 3/4 of the page, you need room to write the augmented matrix plus the step. And then we'll actually do the calculation over here. And if you do your calculation near where your matrix is, when you go back to check, it's all lined up. I would not advise you doing the calculations in your head, because if you make a small mistake, and there's 9 steps and you made a small mistake in the first step, the whole thing's wrong. And if your mistake's at the start, you just have to start all over again, right? So, and if you've got the calculations written out, you have something to actually check. Oh, look, I added 2 and minus 2 and got 4 instead of 0, right? And honestly, usually you can't find your mistake, because you'll just look through quick and it'll look okay. You might have to start again anyway, or at least do the calculation again. All right, so let's put it here. 2, 7, 0, 1, 4, negative 1, 1, 3, 0. My other advice before you start is double check that you've actually written the matrix the same. I've seen that. People copy it down wrong from one line to the next at the start, and they've actually calculated the wrong. Yeah. And when I teach it, I double check like 3 times before I start, because if I just messed up a number, and there might not even be an answer when I was supposed to have an answer. All right, step 1 is what? Make a 1 in that top corner. So are we going to divide by 2, or are we going to switch with one of the rows under it? Switch. We have 2 options, and both of them are nice. Which one do you want to use? So we're going to take row 1 and switch it with, yeah, I kind of like that, row 3. I think that's what I would do. And like I said, be careful to switch the whole row. Okay, now that 1 in that top corner, that pivot, is to make these both into zeros. However many zeros you make is your next step. So you make the 1 in one step, and then you make all your zeros in that column. So this pivot is in a square, and we're making these 2 into zeros. Okay, so we're going to write the step over on the side. So we want to change row 2. So ignore row 3 for a minute, because you always go back and use the one that's the pivot to change to make a 0. So this is a positive 1. What does this one need to be? A negative 1. Same number, opposite sign. So negative 1 times, what row is that in? Row 1. Negative times row 1, and then add it to row 2. And it's always the same. It's the pivot times something and then add to the row you're going to change. So what would this step be? We're going to do 2 steps at once, because we're making both zeros. Here, this is row 3. You're ignoring row 2, because that is not the pivot. Even if that row looks nicer, ignore it. We're not using that. You always have to go back to the pivot, okay? What happens if you start using the other row, it might work, or you might start going in circles, ending up with making zeros that you already made a 0 into a number, and then you have to go back and make it into a 0 again. If you always use the pivot to make the zeros, then that will never happen. So this is a 2. What does the pivot have to be? -2. So -2 times row 1 plus row 3, right? We're ignoring row 2. It has nothing to do with making that one. So we'll do these steps off to the side. So negative row 1 plus row 2. That means just write row 2 as it is. Add them together. And that will be our new row 2. I'm not changing row 1, so when I rewrite it, I can rewrite row 1. Row 2, I just have a new one. And now I'll do my step for row 3. So this was my step for row 2. For row 3, I have -2 row 1. So I'm going to multiply everything in row 1 by -2. Zero, 0, 0. Plus row 3. Row reduction is actually the most important thing in the whole course. Everything we do after this involves row reduction, pretty much. Okay, so do you see that we finished with column 1? That's how we want it to be. So then we kind of move to column 2. You make the 1 first and then the zeros. And then you move to column 3, you make the 1 and then the zeros. It doesn't look good right now, but that's okay, because our next step is going to fix this. So what's our next step? We actually want a 1 right here. And it's already a 1, which is good. You can be happy. However, look at the next row down. You don't need to notice this, and it's okay if you don't. This also has a 1 there, which is good, and it has a 0 here. It would be better to switch. It'll save a step later, because what we want to happen here is have a 0, 1, 0, and that's already like that. So if you noticed it, it would have been better to switch. If you didn't notice, all that would happen is you would make these zeros. That would now become a number that you would make into a 1 on your next column, and then zeros. It would just add actually 2 steps that you didn't need to do if you notice this. So this particular row, because you can always switch with the row below it, if we switch row 2 with row 3, it's going to be nicer for us. That doesn't usually happen, but so all I did was took row 2 and switched with row 3. Don't ever switch with the row above it, though, even if it looks like it might be nicer. Okay, that's the 1, and then we need to make the 0 above and below, because both of these, that pivot is used for any zeros in that column. So we need a 0 here in row 1, and we need a 0 here in row 3. And for both of them, we use the pivot. So this is a 3. What does the pivot need to be? -3. So -3 times, what row is that in? -3 times row 2, and then add it to row 1. -3 row 2, and add to row 1. And then what would be the step here? Yeah, this is a positive 1, so we need the pivot to be the opposite sign, -1 times row 2 plus row 3. So we'll do those steps off to the side. -3 row 2. Let me do that one here. So make sure you're doing it by -3 by everything in row 2. Plus row 1. That's just writing row 1 as it is. Add them together. And that's our new row 1. And our next step, minus row 2, so that's everything in row 2 changing the signs. So 0, -1, 0, -1, 0, 2, and add that to row 3. And that's my new row 3. Nice.
Can I use just like row 2 to plus minus row 3 to get row 3?
You can. Yeah, can you subtract rows instead of that? Yeah, you can. Just be careful that you're using the pivot row and not a different row. That's all you have to be careful of. I always add, multiply by the negative and add. I find less mistakes that way, but you can, yeah. So what's left? Yeah, this -1 has to be a 1. That's easy. We just change the signs, or divide by -1. And these are already zeros, so that once we do that, we're actually done. Okay? So row 3 is negative row 3, or you could write row 3 divided by -1. It's doing the same thing. And just change all the signs. And then this is I, so A inverse is okay, so we write A inverse from here, and then check it. So I'll check on the next page, but we want to check. So we'll write that down. So to check, we're going to take A. I'm just looking back at the start of the question. Multiply by A inverse. And we should get I. Now there's no fractions in this, so assuming I didn't make a mistake, my question is, what do you think the determinant is? So we don't even really know about determinant other than when we did a 2 by 2, you put 1 multiplied, when we switched the rows around, or the numbers around, we put 1 over the determinant. That's what added the fraction into it. If the determinant is a 1, 1 over 1, you don't end up with fractions. So the determinant here is probably 1. Okay, so let's multiply. Minus 6 plus 7 plus 0. That's a 1. Good. Second row, 0, 0, and 0. Good. And our third column, 14, 7 and minus 2 is minus 14, 0 and minus 1 is 0. Now, even though you're happy because it's working, keep going. If it keeps going and it looks like it's the identity and you get it wrong right at the end, it only means you made a mistake right at the very end, the last pivot. Okay? So it's going to work in the first row. That just means you did okay on your first pivot. If the second row works, so it actually works this way, but you have to put A first and then A inverse. Check it that direction and it'll work to tell you where your mistake is. Okay? So negative 3 plus 4 minus 1, 0, and 0, 0, 1, and I'll just do it quick, 7, 8, 1, that's a 0, and then our last one, minus 3 plus 0, 0, 0, 0, and 7 minus 6 plus 0. Good. So what I think I'll do is I'm going to write one down. Yeah, I'm going to write one down and you can try it. Okay? So, let's see if I've got one here that works. So this will have an inverse. So I'll let you write that down. I'm going to stop the video and we'll do the answer to this one after, but I want you to try it. Okay?